We're going to get started here in just a minute. I'm experiencing a small technical difficulty that I'm going to try to fix really quick. So just give me about a minute and a half and I'll see if I can get it. And if not, I'll pivot to something else. Hang tight. Okay, there we go. All right, so we should be good to go. Should be smooth sailing from here on out. Go ahead, I haven't checked too much, but I just want to give people a reminder, go ahead and put an emoji in the Slack thread if you haven't done that yet. Helps us get a sense of like who's around, and obviously gives me an idea that people know where the Slack thread is. Yeah. So today we're going to go over, we've got two topics. They're not huge, but they're important on their own. So I'll try to make kind of a clear distinction between them so I don't get things jumbled up. We're going to be talking about basic functions in Python. So I've talked a little bit about functions. Oops. I've talked a little bit about functions and sort of their role in programming. But we're going to actually get into starting to define our own functions, just simple functions. And we're going to also talk about another data type called a list. So before we start, I want to do a quick overview. I wish I had done this last class we had time after class, and I didn't think to do this after class because I wasn't expecting to have that much time. But I want to do a quick overview of what we've covered and sort of put it in context of what we're going to cover and talk about how things are going to fit in together. And I'm going to sort of draw up a template of what, in my opinion, is sort of the core elements of understanding a programming language. This will be, you might not quite consider this totally comprehensive, but it'll be a good overview and a good place to start. And I would say that if you know these things that I'm going to outline, you would have sort of the core competency in Python to be able to use Python to solve problems and get you past the TI. So cool. All right, so we've covered, so I like to break this into a few categories. Types. Oops. I can hit my keys. Types, functions, which we're going to go over today. Conditions. And loops. So the types we've covered. No, there's an E. Okay. Types we've covered are int, float, bool, string. We talk about none. I think we did talk about none. I think we did mention it briefly. We'll get more into that later. Today we're going to talk about lists. And there's also things that we haven't talked about yet are tuples, dictionaries, and sets. So these are yet to come, and today we're going to talk about lists. So understanding your types in the language involves understanding what kind of operations you can apply to those types and when and where to apply those types, right? So obviously if I wanted to do math, I might not use a string because a string represents characters, or if I wanted to do, obviously if I wanted to do textual analysis or work with text in some way, then I have to use a string. I wouldn't start with floating point numbers or whatever, unless I was going to convert those floating point numbers to strings and then analyze their actual characters, right? So knowing when and where to apply each type. With these ones, I think it's pretty easy. You know, numbers are for number things. True and false is sort of for gating conditions, amongst other things. Good for just keeping track of things that have sort of binary states, two states. Strings are for textual information. None is a value that can act as somewhat of a placeholder, or when Python needs to assume a value, but no value is given, you'll see none. So lists are collections of other values, including other lists. They can even hold tuples and dictionaries and sets. Tuples are honestly really similar to lists, and dictionaries play a similar but also distinct role as well. And we'll get into those. So understanding types can be framed in that way. So what operations apply to each type? Operations would be, you know, what operators apply, what methods and functions utilize these types, and also give me back those types, right? Cool. Functions. So understanding functions is a matter of sort of understanding how and why they're useful. Functions will allow us to encapsulate a process and reuse that process wherever without having to rewrite the process from scratch, right? So if I won't, you know, if I have some code where I'm like, well, I need to take the product of every number starting from 1 up to some number. So some number equals, I don't know, 5 in this case. And if I say I'll need to have a bucket for my product here, and we'll say for I in range 1 to some number plus 1, prod times equals I print prod, right? So this is just a factorial algorithm, and rather than having to like write this out, all this code out every time I want to like take the factorial of some number, and then, you know, like let's say I have some other number that I want to take factorial of, it'd be kind of annoying to have to rewrite this factorial algorithm with some other number every time I wanted to do factorial of something. So rather than doing this, I can encapsulate this process. I can say, well, this is factorial, and I can say def factorial takes in some number n as an input. We'll just call it n, and we'll say oh, excuse me, 1 second, getting a message here. Oh, we are recording. Cool. Good looking out though. Sometimes I can forget. Appreciate that. Let me pull up Slack here. Sorry if somebody was trying to tell me that. I had my phone just turned off, so I didn't see Slack. Sorry about that. Okay. So back to this. So encapsulating this process, you can say prod equals 1 for num in range 1 up to n plus 1, because we want to include it. We'll say prod times equals num. And then we want this function to have the output of whatever prod is after this process is complete. So we'll tell it to output that number, and we'll say return. That's the word that we use for output, or return prod. And this is, I know this is utilizing some bits of code that we haven't gone over yet. So if some of this doesn't quite make sense, if this doesn't land, that's okay for now. Just know that this part here is repeating some process for all of the numbers between 1 and n, including n. And the process is just multiplying the current value of prod times num. And then once that's complete, then we just output prod as the end of this function. And then we can utilize this process. I can just print factorial of 4, 5, 6, 56. I can just do that as many times as I want, and I don't have to rewrite the process. So this is why functions are useful. They save us a lot of work, and they also I mean, really, it is about saving us a tremendous amount of work, not needing to like tailor every algorithm for a specific circumstance, and not needing to rewrite everything all the time. So helps keep your code clean, helps you do your job easier and quicker. And you can make these useful tools that you can utilize everywhere. So if we run that, we should see the factorial of those numbers. Okay, so functions capture a process. And let us reuse it. So to give you an idea of the role they play, we're going to be doing, basically from here on out, we're going to be doing all our coding inside of functions and then calling those functions. So something I want you to take note of is that we have two sort of phases to this. We have the phase where we define what the process is, and we have the phase where we invoke the process. And the reason that it's important to make that distinction is when you're defining the process, notice this value for n is not given. There's no value for n given here, right? So this is a generic process. When you're defining the process, you're defining a generic process that you're going to implement with specific inputs, right? So no value for n is given. There's no specific value for prod because prod is related to n, and so this is generic. Whereas these are specific. I want to know specifically the factorial of 4, which is 24. So 4 is specific. 4 is not generic, it's 4. And the output is also specific, it's 24. So having that idea of your definition, your process being general, and then your invocation being specific, it's a good thing to think about. I guess I should provide some context for why I say that. A lot of times I'll see people do this thing where they'll say, oh, well, I'm defining this process and I have this particular problem where I want the factorial of 5, and they'll put in 5 here. And this is, I get where this is coming from. It's rational in a way to like say, okay, I need to, that's my input, so I should put in some data for it to process. But what do you call this now? There's no, if we look here where I'm using n doesn't exist anymore. I could say 5, but I'm actually just going to get an error here because it's going to see a literal integer, and Python knows that that's not allowed in that case. So it needs an identifier for information that you'll supply later. So anyways, you'll get used to it. Okay, cool. So conditions allow us to run code conditionally. So we have 3 conditional keywords: if, elif, else. Run code if some else run else either not run any special code or run some other code. Cool. Loops. I just gave you an example of a loop down here. We're going to be, I think we might touch on these later in today's lecture, but we'll definitely go over these soon on Monday if we don't touch on them today. Loops allow us to just repeat some process. And the process that it can repeat may involve other loops, right? So I could have a loop inside of a loop. I could have conditions inside of a loop, and I can just have arbitrary code. So the process is just arbitrary code, meaning whatever code you need to put into that process. Oops, my mouse just died. No. Okay, mouse just died. I'm like the last millennial in existence to still use a mouse, but I love it. Okay, I'll use my trackpad. Sorry. All right. So anyways, this is sort of the overview, and this is a real quick overview. I could go into much more depth into each of these, but I wanted to give you a sense of a context of like where everything fits together. Throughout this course, we're going to be covering different types and how to work with those types, when and where to apply those types. We're going to be doing, henceforth, we're going to be doing all of our work out of functions, essentially. Conditions obviously allow us to run code dynamically. They allow our programs to be dynamic. And loops allow us to repeat some process. Imagine if you have, well, this will become more clear when we do lists, but if I have a list of numbers, I might want to like square each of those numbers and save the squares into like a sum or something like that. So whoops. Let me try this. Okay, that'll do. Just give myself some space down here. Good. So let's actually jump into it. It feels so unnatural using my trackpad again. Okay, I better just get used to it. So more quick notes on Slack etiquette. So comment in the appropriate thread or channel. So during class time, for anything relevant to class, just make sure you're posting in the channel. The way I have my setup here is I'm probably just not going to see it if you post it like in the main channel. So if you're posting in the main channel and I'm not responding, it's not personal. I just don't see it because I have Slack up on my phone and I'm looking through the thread for the class. It also keeps Slack nice and clean, so go ahead and do that. If you're having trouble with that, DM me, and or if I see you do that, I'll DM you and try to help you out. So also a quick note on like sending formatted code. So some people have asked me how I send code in like formatted code cells. So there's a few ways to do this. If I let's say I want to like just format something in line, Let's say I have some code that I'm talking about, like x equals 9. And my question is, why does x equal 9? So I can surround, this is, you can imagine this in Slack. I'm just not showing Slack because I would have to change my screen share and all that. So you can surround the variable or whatever in backticks to make it clear that it's code and not just part of your text. You'd probably be understood either way, but it's nice to just see clearly formatted text. So if you don't know, the backtick key is not the single tick quote or the apostrophe key. It's a different character. It's, for me and for most people, it's going to be, if you're using a Mac, it should be below your escape key, to the left of your 1 and exclamation point key, and above your tab key. So that's one thing you can do. If you want to do a whole block of code, you can do triple backticks like this, and then you can say, well, you could have a whole block of code like this factorial function, for example. So this really helps if you're sending me code during class time, if it's unformatted, if there's more than really 2 or 3 lines, it becomes difficult to read, especially for me. And I won't have much confidence in my ability to like really help you out with that. So if it starts to look confusing, I may just ask you to resend it formatted. You can also edit messages in Slack. So if you go look, I think it's on the bottom right hand corner. Let's look at this. And yeah, my windows are moved around again. So if you hover over a message that you sent, excuse me, it'll be in the upper right hand corner. There'll be 3 vertically aligned dots. It'll say more actions, and you can go down to edit message or delete message if you want, but you can edit the message and then put in the backticks that way too. So I won't be mad if if you're not doing this perfectly yet, but it is kind of limiting as to how much I can help with code that's not clearly formatted. Cool. All right, we've got a breakout. So I'm just gonna, whoops, do this. Paste this in. There you go. All right, go ahead and finalize your answers. Go ahead and get in whatever you've got. Oh, it's clear. Excuse me. A glare coming through the window that I have to deal with. Oh, maybe that'll be better. Okay. So what are the 4 scalar types that we briefly discussed? Obviously, just went over these. So that'll be, oops. Yes, I am screen sharing here. Int, float, bool, string. So scalar types just mean simple types. They have a single state, and they don't, the object that represents that state doesn't itself change. So they don't change their size or change their value. They just are what they are. And we'll get into some other types that do that today. We'll get into lists. Print, this gives us an underflow error or rounding error. What does 3 equals 3 evaluates to, or evaluate to? This is going to be true. And then 2 not equals 2 is false. Cool. All right. We've got another breakout here. Make sure this is going to paste correctly. Ah, special characters. I knew it. I knew there was going to be something weird. Just had a feeling. This is kind of a weird one. If you look at what I was just doing, I was replacing quotes with other quotes, but it's kind of hard to see. These are non Unicode. They look like quotes, but they're slightly off. They're non-Unicode, or excuse me, non-UTF-8 quotes, which means they will not run. Python will not be able to understand what they are. Cool. This should work. Paste that into Slack. And go ahead and submit your answers in a formatted code cell. All right, that's a little shy of 3 minutes, but that's okay. So we want to run this code for these 4 values of x. This is a good example of why functions are useful, because I would have to run this code, like rewrite it every single time for each value, and that's just, that's a lot. So I'm gonna be ornery, and I'm just gonna do this. I don't know what to call this. Def breakout 2. I don't know. Breakout 2 takes in x, and I'm just going to call it x because that's what that variable is called, and I don't have to rewrite it or something. And then since these are also called x, we'll have a little shortcut here, a bit of a shortcut. And there we go. So that should run it for all 4 values. Nice and easy. I got nothing. High five, and evens. Cool. Now, obviously, I think the idea with this is that you look at this and analyze it, and kind of run the code in your head, which is a good exercise to do. But so far as I'm concerned, I want to get people in the habit of running their code rather than trying to visually analyze code. The skill of visually analyzing code is obviously useful, but it's not as central as being able to run your code and potentially debug problems or understand, okay, how can I just implement this? How can I get a quick answer? When you're in your day-to-day and you're coding, you're working through a problem, that's the thing that you default to. Like, I don't want to think about this. I'm going to get Python to do the heavy lifting. And developing, strategies to make that easy, i.e., how do I turn this into a function? And that'll make calling this and running this really easy, So little things like that. Knowing how to manipulate your code to give you output that's useful in order to help you understand it. And I think if you do that a lot, you'll actually develop over I would say probably a shorter time than you'd think. You'd develop a sense of what your code is going to do naturally by looking at it. So it's sort of it seems roundabout, like run your code and then you'll understand your code before you run it, which I think is a lot of people's assumption, that we want you to understand it before you run it. I think that is the assumption in a lot of other fields of academia, especially STEM fields. Like if you don't understand the math, you're studying you're going for a math major, like that's a problem. And I think even in traditional comp sci, they want you to. I remember I had a professor who wanted us to submit our handwritten Java code as for our homework. He wanted us to write it all out by hand, and it had to be perfect. It had to have all the correct syntax if we missed a semicolon and all of that. And we're sort of on the honor system to do that all without like coding it first and then writing it down once we knew it worked. But that's definitely what I did, and that's what I think is the right thing to do. Code it out, make sure it's going to work. The Python interpreter is so much, it's many more thousands or even millions of times better at accurately analyzing Python text than I could ever be. So why not use it to your advantage? Anyways, if you want to like sit down and think through the problem too, I'm not going to tell you not to, but that's not the only thing you should do. And if you find that difficult, that's fine. It can be challenging, especially when you're not running your code to get a sense of what it does under certain situations. Cool. We've got, looks like a question here. How come 80 doesn't give me 10? So let's look at this. Let's isolate this test. Okay, so if x equals 80, 80 mod 5, what does x equals 80 give us? High 5? So 80 mod 5 equals 0. This statement is true. So none of these other ones run. So since this is the thing about, this is a great question actually, because this is an important thing to understand about chaining conditions together. Like all of these conditions, these are not independent of each other. This is a single system. So what this is saying when you have ifs and elifs and an else is only one of these consequents are going to be run, right? So what I mean by consequent is this is your consequent. Your consequence for the condition being true. So if condition true, then run the consequent of the condition, right? So the first consequent the first condition that's true is 80 mod 5 equals 0. So if I divide 80 over 5, I have a remainder of 0 because 5 goes into 80 evenly. So what happens is this is true. And since this is true, the Python interpreter doesn't even bother checking anything else. It doesn't even bother like looking to say, oh, well, maybe there's something else that's also true, because what would that mean? What would it mean to have multiples of these true when these are chained together, right? Maybe, I mean, I think what it would mean is that you have multiple consequence run. Now, you might want to do that. You might want to say, you might want to print all of these out if any of them are true rather than just one of them, right? So you might want to use consecutive ifs. So that behavior can be recuperated, but you have to use consecutive ifs. And then in this case, we can't use an else because this else actually pertains only to the if above it. So that's going to be, we're going to get, I got nothing for all and only odd numbers, right? So we would have to reconstruct this. I think it would just be, we just have to say if, and then we'd have to provide like the negative conditions for all of this, which would be if x mod 2 not equal 0 and x mod 5 not equal 0, I think. So if we wanted any of these that happen to be true to run, these would all need to be ifs. Let me know if that is a helpful answer. This is actually good. This actually kind of speaks to the point I was making earlier, right? Run the code first, and then once it does something that you don't expect, then you have grounds to go through and analyze it by eye and try to like recuperate that understanding and reconcile what the code did with what you expected it to do. So, you know, you'll still get plenty of time. You'll still have plenty of opportunity to like look through your code and try to understand it. You know, it's not really taking the easy way out. Cool. So the question is, why wouldn't you want to put the if and first to get a better reading on the numbers? Yeah, I mean, I honestly, I agree. This question's this code is a little bit silly to me because of that. So the question is like, why wouldn't this go first? Like if we swapped these two conditions, because, you know, if we have it the other way, essentially this one's never going to run because the one before it is going to be true. You know, the second condition is predicated on something that's being checked in the first condition. So it's sort of under a shelter that it'll never run under, you know. Because if x mod 5 is true, then the first one will run. And in order for the second one, if x mod 5 is equal to 0, the first one will run and the second one won't even be checked. If it's not 0, then the second one will be checked, but in order for the second one to run, x mod 5 has to be 0. So this is actually a good example. I'm glad you brought this up because you have to watch out for this, right? So the order does matter in the conditions. So if I want all of these to actually run, we might do that, and that'll probably change our output. Oh, I was like, what? I forgot to actually take the consequence of each condition, so I forgot to swap those. So give me 10. Yeah. Okay. Cool. I like these kinds of questions. The details with the if statements are important to suss out. So keep those coming. Also, let me know if that's helpful, if that answer is helpful, or if you want to follow up to that. All right. Using print to output to the console. So print is a function that takes a value passed into it. So when earlier I gave an example of defining a function, which is a generic, you define a general process or generic process, and then you invoke it with specific information, you get specific information out. Python has a number of functions built in. You've seen me use print. So this is an example of a built-in function. It's kind of a special case because print doesn't have an output in the way that we think of most of the rest of our functions as having. The output of print is actually none. The return value of print is actually none, but it does have a behavior that we can describe as an output, obviously, because it's making things visible on the terminal. So think of print as write this to the terminal so I can see it. So it's very useful. It's good that it's built in, but it doesn't, it's sort of a special case because not a lot of the functions, a majority of the functions that you're going to be writing are going to have different behavior than print. So when we give print an input, so obviously I have to give print something to print off. So the thing that I give it, we refer to as an argument. So we'll give print an argument. This string is my argument to print. And we say we would pass this string as an argument to print. So we would pass this to print. So pass in this context means to give argument to supply an input to the function. But we'll use that term pass. So I'm passing this string to print, and obviously if I run it, I expect to see that printed off. So this is a good point. Print is in your core tool set for checking what you expect is happening in your code. Print function is fundamentally different from the return keyword, which I'm kind of just talked about. Oops, no, don't want to do that. Kind of just talked about a little bit. Return is what tells our function The return keyword bears only on functions, and it specifies what the output of the function is going to be. What the output is in terms of its return value. If we print off the call to that function, we will see what the function returned. So we call the function, it gives us a return back. If we print that off, it's like we're printing off whatever that function returned. So it's definitely easy to get these two get print and return conflated, but they do different jobs. It seems like I don't need print to see my output in the terminal. You do need print. Nothing is going to display on the terminal unless you use print. I mean, unless you want to make the exception of like input, but input has print functionality built into it. Right. So these are the only two things that are going to actually make something visible on the terminal. For example, in the recent breakout, you just put print. Oh, breakout 2, right. So that's a good point. This is a good point. In the recent breakout, which I lost, oh, right here. So why didn't I print off these calls? I'll leave it all to you. This is a great question. So the question on the table is, it seems like I don't need print because sometimes things are printed off when I'm not using print. So I'm not printing these calls here, and usually I would, but I didn't in this case. I'll give you all a second to see it, and go ahead and put it in Slack if you see it. So why does this display without me printing off the function? Cool. All right, yeah. So what I'm doing here is I'm invoking the function. I'm saying, hey, go ahead and run the code in that function. And the code in that function utilizes print. So print is used internally in here. So this is an example, very much an example function. In reality, we would probably have these as return values. And then we would print out the calls. But this is just a little example function, so either way. Good question. All right. So functions, I think I kind of covered this already. Functions can be thought of as ways to create repeatable procedures. Naming the function, giving it parameters. So this is worth mentioning. Let's look at that factorial function again. Well, let's just look at an example. So in the examples that I've given, I've always named at least one input. The input is optional, and you can also have multiple inputs, right? So I can have a function that takes however many inputs that I need, right? So let's say add nums. So let's say I just want the sum of two numbers passed to this. So we'll say A and B. I can do that. But I technically can write a function without inputs, although it's not often done. The same is true for return. Return technically is optional, but it's really rare that you write a function without a return value. And I wouldn't even worry about thinking it about like when under what circumstances do I not need a return? Like, don't even worry about thinking about that. Just assume that all your functions need a return for now. If you need to write a function without a return, I think it'll just be clearer. It's also just not common. So we have a comment here, return and print seems similar, but one is internal. It seems, and print is external. Return and print do seem similar, but I want to be clear about this. Their roles are as different as apples and astronauts. They're like categorically very, very different. They both describe and cause something that we would think of as an output, although the context of what we mean by that is very different. The context of a return is it says, here's the value that the function shall be evaluated as, right? So if I take in A and B and return the sum of A plus B, this is not a, not a mind-blowingly complicated function. So this, when I call this function, see, I just use print by default, so that kind of makes things confusing. Add nums, and we'll say 3 and 4. So this is going to give us 7. 7 equals 3 plus 4. And I can capture that in there, right? So this is kind of an important thing. Like when I look at this on line 100, this call to add nums, I do not see a function call. I see the thing that it returns. I try to see it as the thing that it returns, because wherever I call this, the way that it's going to behave in my code is as the thing that it returns. So we could say 10 is equal to this plus 3, right? And why can I'm not adding 3 to a function call. I'm calling a function that gives me a return value. That return value is put in place of this function call. So it says add nums 3, 4, plugs in 3 for A, plugs in 4 for B, and it returns 3 plus 4, which is 7, and it replaces this function call with the thing that it returns, which is 7, right? So that's a kind of output, and that's distinct from, like, I want you to think about like that kind of output as very different from make this visible on the terminal. Print says write this to the terminal, make it so that I can see it on the terminal that I'm running it in. So that's I get where you're coming from. I definitely remember going through this when I was new to coding. And I see that this is a quandary that comes up maybe for most people. So it's totally fine. Like, I get where this is coming from, but it took me I think too long to realize, oh, these are very different things. So I just want to like focus on that because perhaps you can benefit from from my having taken a long time to have realized that. Okay. So things we need to consider when making a function, how to name the function and what to call it, what the function expects as arguments, what its inputs are, what its process is, what it does, and what its return or its output value is. If there is one, which we're just going to say there is. If you're wondering, should this function have a return? The answer is yes. For now, if you're looking for an easy rubric, the rule of thumb is yes. Your functions will almost always have at least one input and almost always have a return. So we've looked at a few basic structures of functions, but let's just be specific. So we have the def keyword. Def is short for define. So when we start a line with def, Python knows we're going to define a function, and then we name the function. So function name, and then we put parentheses. Now inside the parentheses is where we put our arguments. You might say, well, in the rare case that you're writing a function without arguments, you might say, oh, I'll just skip the parentheses. You can't skip the parentheses. If you want a function with no arguments, you just leave the parentheses empty. But again, you're probably going to have at least one argument. So yeah, so def keyword, function name, parentheses, and then inside the parentheses, you give a name. Think about it like a variable with a name but no value yet. We supply the values when we call the function. So since we're defining it, this is a generic process, which means specifically that we're not supplying values to the arguments. So we'll just say A and B. I could have C and D and E. I could have as many as I wanted, although I've heard different rules of thumb about this. I don't know if I would commit to one myself, but I've heard different people say, like, if your function takes more than 3 arguments, you could probably break it into 2 functions, one that takes 1 and one that takes 2. Or I've heard other people say your function should never take more than 5 arguments. I'm not sure that I would commit to a rule of thumb around that. Your function should take however many arguments that it needs. If it starts to feel complicated, then consider breaking out your code. So I don't know if there's like a hard line in the sand that you should follow, but in general, most functions will take between most functions will take one or two inputs, sometimes 3, rarely 4. Yeah. I think it's something you just develop a feel for. If it starts to feel too complicated, think about how you can break out some functionality maybe into a different function. So, or not, maybe what you're trying to do, maybe your function needs 8 arguments, who am I to say? And then you have your, whatever the code of your function. Let's just write factorial. We'll take n, you've seen me do this, prod equals, and we'll make a variable. So here's the process of my function. This is the what it does portion. We create a variable and we run through a loop. We multiply the element in the range by that variable, etc. And then we return the value of prod. Cool. So think about this like, what should it be called? What should it do? What are its inputs and what are its outputs? Input, process, output. What does I mean? We're going to be covering for loops in more depth shortly. For now, I is just it's a variable name that I chose. I could call this, I could call this poodles. Excuse me, if I wanted to, but yeah, that's what that is. But yeah, we'll be diving into these on Monday. So apologies, this is a little bit out of the scope of what we've covered, but we'll be getting into that shortly. Okay. Parameters, I think we've covered that well enough. Oh, I see. So there's something a little bit funny. I'll just use this one as an example. When we define a function, the technically correct name for its inputs are parameters. We call them parameters during definition. When we invoke the function, we call it an argument. So a parameter is the word we use when we define it. When we invoke the function, we call it an argument. For now, you can see them as synonyms. In practice, everybody in the industry always uses the word arguments for both. It is technically incorrect, and it's just something that everybody does. I do it. Everybody on my team does it. Every programmer I've ever talked to just says arguments when they mean parameters, and we all know it, and it's fine. So just know that there is a distinction. You may sometimes hear me say parameter. Just know that I mean argument. Think about it for now as a synonym for argument. I'll use the words inputs and arguments and parameters interchangeably, but usually I will use the word argument. So if you want an easy thing to lean into, just when you're talking about the input into a function, just call it an argument, and you would be understood perfectly fine. So defaulting arguments. Well, let's just use this one again. Well, no, let's use a different one. I feel bad that has a for loop in it. Sorry about that. I will try not to do that in the future. Use code that we haven't covered. Excuse me. So let's say def add nums, takes in A and B, returns A and B. Now let's say that there's a behavior that I want to add into this function. What am I doing? Add nums for. So let's say I want to say if I only pass it one argument, I just want it to add 10 to the number that I pass it, right? So currently, if I run this function, I specified 2 inputs, but I gave it 1, or I specified 2 arguments and I gave it 1. So if I run this, I'm going to get a type error. It says add nums missing 1 required positional argument, right? So a positional argument means that it knows which argument I mean based on its order that I pass it in, based on its position in terms of where I'm passing it into the function. So it knows that 4 is for A because 4 is the first one and A is the first one. And then it knows that 3 is for B based on their positions, their order. So it's missing 1 required positional argument that I called B, and I just didn't supply it. So in this case, I want to tell it like, okay, sure, fine. If I don't supply a second argument, I just want you to assume that the second argument is 10. So what I can do is I can set a default 10. Now I can override that default. So if I run this now, I'm going to get 14. But I can override that default by just passing in a oops. I'm like, what happened? A plus B. I can override that default by just passing in another number for B. So I still have the original functionality. It still works like a regular function. But yeah. And I can also default, I can default all the arguments if I want. Let's just say I want them both to be 10. Now I could call this function with no arguments, and it's going to give me 20 back, which is kind of weird, but it's valid code. So now they're both 10. The thing is, I can I can't supply an argument or a default argument before a non-default, right? So all of my non-default arguments have to come before my default arguments. And think about that for a second, right? Because if I say, hey, A defaults to 10 and B doesn't default to anything, this is going to be actually a special error. It's going to give me an error on this line 119 in the definition. So and it's specific to this particular thing. Non-default argument follows default argument. So this is a syntax error. Python says you can't do that. And the reason is, look at this call. Which one should for apply to? Well, Python assumes that for applies to A, which is 10. So it overrides A with for. So what's the point of having a default, right? I can never utilize that default. I can never use this with one argument. I still have to use it with two arguments. So Python's just like, this isn't useful. It's an anti-pattern. It's not possible to be useful, so it just prohibits you from using it. So if you use default arguments, all of your default arguments have to come after your non-default arguments. Print and return are different. I think we went over this, at least to my satisfaction. To be clear, I know I kind of made a big stink about this. I don't want to I don't want anybody to feel bad for thinking about that. To be clear, I definitely took me a long time to really get that solidified, and once I did, it was like this big epiphany. So it's an important enough thing that I just want to make it clear. It's a common misunderstanding, not a big deal. I don't mind going over it as many times as is necessary. So don't feel ashamed. It's all good. F strings. Okay, so we talked about strings. So let's say I have a string and I want it to print out information, or I want to print a string out that contains information dynamically. So let's say we have a name. Yeah, let's say we want to print somebody's name is their age, years old. So if I say name equals Sally and age equals 39. So this should say Sally is 39 years old. Obviously, if I run this, it's just going to say name is 8 years old. But what if I want to plug in this variable into here? Well, in the case of print, and you might already know this, I could say name is age is age years old. This will work in the case of print. Comma. So that'll be okay in this particular case. But there are times when you want to like turn this all into a string quickly and easily. So there's something called a format string, which allows us to format information into the string dynamically. And the preferred way of doing this is to just put an F for format in front, directly in front with no space. No space. So my syntax highlighting breaks a little bit. I don't know if you can see that. Probably can't see it, but the F changes color from green to white if there's a space. So no space there, just F and then the string. And then the places where you want to format information, you put curly brackets around it. So notice how that syntax highlighting changes, right? So if I put curly brackets around it, name is age, years old, it's going to change. Now, if I don't have the F in front of it, it's just going to say name is age, years old with curly brackets around name and age. So if I want that information formatted in, I have to put the F in front of it. And this will say Sally is 39 years old. Okay. Input. So I use the word input, and I never use it unless the topic is the input function. I almost never use it to describe the input function. So that can be a little bit confusing because people will learn the input function and I'll say input. I almost always mean input in the context of like an input into a function, i.e. an argument. Like I said, I'll kind of use the term argument and parameter and input interchangeably. But there's a function called input, and it takes input from the user. It's really cool. You know, you now have kind of a complete set of tools where you could write a text-based adventure game or something with like input and print, which would be a fun challenge. So I think people will look at this and they'll be like, "Oh, great! I'm going to use it everywhere." And it's fun. I mean, you can take input from the terminal now. So if I run this, so it says please input a number. So notice that input is going to print out whatever it's is passed as its argument. So we pass in this string to input, and it's actually going to print that out, and it's going to wait for me to give input. So I click in my terminal, and then it says please. Oh, it says excuse me. Please enter your name. So my name is Clark, and it says hello, Clark. Right, so it waits for user input before it continues on to the rest of the function. So this can be useful if you want to like create like a wait state as you're like kind of iterating through something, and you can kind of check things and it'll wait for you. You can look at output and kind of crawl your way through some output. This might be a lesson that I think people kind of have to just figure out by doing it, but don't use input all over the place. Like when you're trying to test some code, having a lot of input calls can make it like confusing. You have to like supply a value by typing it in every time. If I were actually testing this, so as I'm developing code, I would much rather not use input. I'd much rather just bake in a string and just say like Clark, because this is going to run right away. I don't have to type in my name every single time. So this is just going to say hello, Clark. And that can help me get this function up and running. But I would say, you know, input is nice. Like once you have all your stuff working and you can like implement something, you make a little terminal tool or text-based adventure game, whatever, but it can feel a little burdensome sometimes. But yeah, feel free to play around with it and discover that for yourself. That's fine. We've got, this breakout is violating everything that I just said about input, by the way. Huh. Yeah, I think we can skip that one. Print is not returned. See, even the material agrees with me. Cool. Variable scope. So here's something that's worth covering. Let me actually get a sense of where we're at. Okay. I'm going to assign the rest of these breakouts as part of homework. I just want you to go through the breakouts. Feel free to share your answers in Slack whenever you choose, or not, that's fine too, but just do the breakouts as part of your homework. So we're running kind of lean on time, so I'm going to cover variable scope, and then we're going to move on to lists. So variable scope. So here's something you are allowed to do. Well, when I say allowed, you're like, Python will let you do this, but I'm going to show you some code, and I want you to remember that this is not something I'm telling you to do. It's something I'm telling you to avoid. So let's say x equals 10, right? So in this case, we would say x is a global variable. And what that means is it's a variable that exists throughout the entire, well, this whole file. Actually, it doesn't exist above line 150, but it exists in the global scope. It's available to everything below it. So it's globally accessible. Let's define a function. Let's do add nums again. Take in a and b. If I have a variable, so I'm just going to create a variable inside of this function. This variable is referred to as a local variable. So it does not exist outside of this function. I declared it inside the function. The reason I know that is because it's tabbed in. I keep forgetting to kind of emphasize the importance of tabbing. Right, so the reason that Python knows that some code is a member of a given condition or loop or function is that it's tabbed in underneath the head of that construct, right? So this is the function head. Everything inside of that function we can call the function body. So this is in the body of the function because it's tabbed in, and we know that since this variable is declared inside the function, this variable is local. It is local to this function. So I can print y here. So I can print y. Value of y is 20. But I can't print y here. Right? So if I tab this print out of the function, I'm now printing in the global scope. I'm not printing locally inside this function. And this y does not exist in this scope. So if I try to print y here, name y is not defined. So Python is just like, I don't know what you mean. There's nothing called y. It is not aware of any variable called y at this point. So that's something to know. This is good. This is a good thing. You might think, oh dang, so if I declare a variable inside of a function, it's like, it's going to be lost to the rest of my program. That's a very good thing. The reason that that's a good thing is, imagine if I say, well, y equals horse. Well, horse is pretty different information than 20. And if I could change the value of y to horse, and it would change it inside this function, what would that mean for this function? You know, like if I use, like if I return a plus b plus y, well, I'm doing 1 plus 2 plus horse. So it's very useful that this is, you know, that variable only exists inside the function. Okay, so this is good. So the part that you don't want to do is have this. So let's say I have this global variable y equals 20, and my function returns a and b, which are its inputs. That's great. And then I'm just going to include this global variable. So this is, I kind of preface this by saying, you know, this is code that I don't want you to write. This is what I meant. So where we have a global variable being just arbitrarily utilized in the function. This is something you always want to avoid. It is unfortunately valid code. I wish Python would throw an error for this. It doesn't. It allows you to do this. It's just like, sure, that's fine. But yeah, let's look at this. So, well, first of all, let's print the value of y here, right? So this is going to give us 1 plus 2 plus 20. That's our expected behavior, unfortunately. So the value of y is 20. Notice y does exist in the global scope. Does y exist in the local scope? Let's ask. Let's run that. One second, sorry. So we can see that y does exist in the local scope. So it exists in the local and the global scope. So the value of y is 20 in the local scope too, right? So the problem with this is if I say y equals horse, what does that mean for my function? So I just broke my function because I made some variable called y, and now it's trying to add 1 plus 2 plus horse, which it doesn't know how to do. So it says type error, unsupported operand for int and string, right? So hopefully it's clear that this is why this is an anti-pattern. Okay, so just let's walk through this really quick. This says y equals 20, and I want to do whatever a plus b is plus 20 for whatever reason. That's the behavior that I expect for this function. And then, you know, I invoke my function somewhere, but somewhere I reused the name y for something else. And I said y equals horse for who knows what reason. Because I had some other thing that I was doing where I wanted to use the variable y for the word horse. Okay, so this function is now completely useless. It is forever broken and meaningless. So you never want to utilize the value. You never either to you never want to utilize a value that you didn't create in the function or take in as an input. If I want y in my function, I could specify an argument for it. And then, you know, if I wanted it to be 20, why don't I just default it? I could do that. Now, maybe I know I don't want to do that, and I don't want to take in even a default for y. You know, I'm just going to say y equals 20 in the function. This is fine, right? So in this case, I have a local variable that has the same name as a global variable. This is now okay because if I create a local variable, that overrides the global variable in the local scope, right? So in this function, y is now always going to be 20 because I'm just saying like use the local variable y. It's going to assume that I wanted to use the local variable, which is nice that it assumes that. It's very necessary that it assumes that. So if I now do this, well, my function now takes in its inputs and it brings all of its resources that it needs to the table internally. and it doesn't rely on any global variable. Can I provide an example of a default variable declared before a non-default? I did provide an example of that. Actually, I'll just do it really quick here. So a default variable declared before a non-default. So if I say a equals 100, this is going to be a special case error. So it says non-default argument follows default argument. So that's something we can't do. And you can, I explained this a little more in depth if you go back and watch today's video once it's uploaded. A equals 100 is a default. You can try this out in Replit if you want, and look back through the video for today, and I'll describe that more. I'm also, yeah, absolutely, and I'm also happy to talk about this after class or perhaps on Monday if you want. I'm happy to go over it more. Cool. Variable scope. So hopefully that gives you a sense of some ins and outs of functions. There's a little bit to know, more to know with functions, but that'll at least give you an idea. Okay, so let's talk about lists. We've only got a little bit of time left. So we're going to go over lists. So we're changing gears. We were talking about functions, and we're now officially changing gears. So lists fall into the category of types. Lists are a data type in Python. We're going to talk about what a list is. We're going to talk about the range function and range objects, which are similar to lists. They give back an object that is similar to a list. We'll talk about indexing, membership, slicing, nesting lists, mutability, copying, and mutating lists. Cool. Okay, so let's create a list. So I'm kind of lazy. Often when I'm working with lists, I'll just make a variable called LST. Reason I don't use LIST is this is a built-in function and a built-in type identifier in Python. So this is a word in Python that is already used for something. This is kind of weird behavior that Python will let you override this. So I can say list list equals something, and then I just I override that function and it doesn't exist. So I don't want to call something list. I want to call it lst. So let's make a list. So in order to make a list, we use square brackets. This what we call square brackets because they're kind of square. Let's print out the list. So this is just an empty list, doesn't have anything in it. Just square brackets. If I want to put objects in it, I just put them in separated by commas. So let's just have a list of integers. So let's print that list off. And this might seem like a given, but notice that I put these in this order, 3, 6, 1, 9, whatever, and I get it out in the same order. And that's important because, so these are what we would call the elements of the list. So the elements are these numbers. They're the literal values that are held within the list itself, the elements held by the list. Each element is implicitly associated with an index. So we start at 0. This is kind of a funky thing that has some getting used to, takes some getting used to. So I can retrieve items back out of this list by asking for the item at a specific index, right? So I don't have to write code to make the indices exist. The indices automatically exist, and they're automatically associated with the elements, right? So the first element in the list is going to be at index 0. So 3, the element 3 is located at index 0. So if I want to know what the value of my list at index 0 is, I can specify the list that I want, and then after the list, I'll put square brackets. And Python knows that I'm going to index into the list now. And then inside the square brackets, I'll put the number of the index whose value I want to retrieve. So list sub, the way we would say this is list sub 0. If you're familiar with like subscripting in like mathematical notation, if you ever see like x sub I or something, where it's sort of the opposite of like raising it to a power where you have it like lower, I is lowered. It means the ith element of a collection of elements in X. So this is models that same behavior. So this is list sub 0. That'll be the 0th element of the list, which is really the first element. And that'll be 3. So if I run that, that'll be 3. So I don't need to hold, excuse me, it's not required that I hold data types of all the same type. I can mix and match types, so I could have floats, and I could have strings. I can put whatever I want into this list, including another list. So I can have whatever I want in my list. Any other data type. And I can retrieve that type by specifying whatever its index is. So if we look at this, the element at index 4 is going to be 0, 1, 2, 3, 4, and that'll be that 5.4 right there. What happens with negative numbers as elements or as indices? I presume you mean as indices. Will the list within the list be indexed as one place? Yes. Yes, so we'll get into nested lists in a second. We'll talk about that. So we have a question about like, well, what if I pass a negative index? This is a great question. So if I pass a positive index, 0 is, I don't know, I have 0, 0, but 0 is the first element from the left. If I pass a negative index, and there is no negative 0, but there is a negative 1. Negative 1 is the last element from the right. So I can count from the right to the left with negative indices. So negative 1 is 5.4, negative 2 is 9. So I actually have 2 ways of referring to each index. So I could say 0 is going to be my first element. 0 can also be referred to as 1, 2, 3, 4, 5, negative 5. So that'll be negative 5. So both of these will give me that first element 3. 6 can be referred to as 1 or negative 4. The 1 can be referred to as list sub 2 or list sub negative 3, etc. Now for the question, I have 1, 2, 3, 4, 5 elements in this list, which means my maximum index is 4. What happens if I ask for a number greater than 4? I get an index error. It says list index out of range. So I have to be sure that whatever number I'm using to index is within the range of the list, right? So the maximum index for this is 4, and I'm asking for list index 5. You know, what would be your best guess about what that should do? If you've ever done any C programming, you know what C does, which is terrifying. C looks at the the fourth element. C looks at the memory address where that list begins, and the list has, it's called an array in C. And the array has 5 elements in it, and it goes 0, 1, 2, 3, 4. 4 is the end of the list, and then it gives you whatever is at the next literally contiguous byte in your memory after that. It just pulls the information from that byte. So Python fortunately gives you an error, and it's like, whoa, I don't know what you mean. You can't do that. So it's nice that it limits us from being able to do something insane like C lets you do. That's not a knock against C. If you're a C programmer, I personally love C. I love that you can do insane, horrible things like that. It's fascinating. But Python makes our lives easier. The range function. Okay. So there's a function that's built in called range. And range, let's think about range. So this is not technically correct. Range does not give us a list back, but you can think about it as giving us a list back because it's similar to a list, and we're going to cast it as a list. So I'm going to say my range equals, I'm going to say list, L-I-S-T. I'm going to use that built-in function list to turn this range into a list. So a lot of times you want to just generate numbers between like, I don't know, maybe you have a problem where you want to generate numbers between 2 and 15. So I'll say 2 and 15. If I want to generate numbers between 0 and some other number, I can just pass in one argument to range. So if I want to generate numbers between 0 and 15, range is going to give me 15 numbers, but the numbers are going to start from 0 and they're going to go up to 14. So let's do this with a smaller number. Let's say 5. 0 to 5, a range from 0 to 5 is 0, 1, 2, 3, 4. So the maximum number in this range is going to be 4. If I want to include the boundary here, let's say I have n. This makes more sense with a variable. N equals 5. If I want to include n, I can say +1. And this is really common to do when you want to include the upper bound of your range. So if you pass one argument to range, it's going to be used as an upper boundary, and it's going to start at 0. It's going to assume you wanted to start at 0. If you want to explicitly start at some explicitly stated lower bound, you pass that first. So if I want to start at 4 and go up to 8 inclusive, this will give me 4, 5, 6, 7, 8. So that's 5 iterations. Oh, I'm like, why didn't I see anything? I have to print. Okay. You can play around with this, like play around with different values. List of range 5, etc. Cool. So here's just some different examples for range. I should supply some context to this. Let's say my range equals range. So I'm going to show you what happens if I don't cast it as a list. Range 5, print my range. It's going to give me a range object starting from 0 to 5, right? So it doesn't quite display in the way that we would would be used to it. So I'm really casting it as a list for display purposes. But generally, you can just use range and just assume that it's going to behave like a list in most cases. If you get an error or something, just try casting it as a list, and that may help solve the problem. So range is a really useful one, and you've seen me use it in the factorial problem that I gave. We just talked about indexing. So indexing is the example that I gave here with the square brackets after the list. Membership. So there is, remember when we talked about Boolean operators, and I talked about not, and or. These are, or excuse me, these are, I always call these Boolean operators, these are logical operators. They give us Booleans back, so I don't know. That's a mistake that I keep making, but the correct term is logical operators here. There's another one that I omitted because I wanted to talk about it when we talked about lists. So you can test, it's called a test for membership. So let's say I have my list equals, just make a random list here. And I want to see if, if hello is in list. If hello is a member of my list, print hello in list. Obviously, hello is not a member of my list, but 3 is. So 3 in list is a test for membership. This gives us back a Boolean value. Excuse me. I'm getting hiccups. Apologies. Excuse me. So 3 in list is true. It's true that 3 is a member of this list. A lot of times you also want to test if something is not a member. You can say 3 not in list. So let's just run this really quick though, just to prove that it works. So if 3 in list, print 3 in list. And if 3 not in list, print 3 not in list. Obviously 3 is in list, so 3 not in list is false because 3 is in list. So if I say if hello is not in list, print hello is not in list. So you can test for membership. I guess you could say you could test for membership within, and you can test for absence with not in, excuse me. Very worth remembering here. This can be, this little thing can really save you a lot of work. So remember testing for membership because that's a very useful thing to do. So slicing, let's talk about slicing real quick. Slicing is like indexing. Imagine if so let's look at indexing again. So if I say list and I want a specific element, just one specific element, let's say I want this 4. Well, so what index is that 4 at? Go ahead and put it in Slack. Yeah, there you go. Y'all are on it. Oh, sorry. It looks like I missed somebody's question and somebody is like asking them to, apologies. Feel free to re-ask your question if I missed it. Okay, sorry about that. So if I want that 4, that'll be at index 2, and y'all just nailed that one. So that's 0, 1, 2, index 2 is at 4. But let's say I want a sublist, like I don't just want the 4, I want 4 through 0. So I can slice. I can do what's called slicing. So what I like to do when you slice from a starting index to a stopping index. So what I like to do is put in 2 colons here, and this is going to break. You can think about this as specifying 3 places in or in the slice. So I'll say the first section here is where I want it to start. The second section is where I want it to stop. And then the third section is the step, the interval that I want to use between elements. And we'll get to that one in a second here. But so the first one, I want to start at 4. Remember, I want to go from 4 to 0. So 0, 1, 2 is 4. 3, 4, 5 is 0. So this is a little tricky because the lower bound is included. So if I say index 2, it's going to include whatever's at index 2. The upper bound is excluded. So it says go to index 5, but don't include it, right? So this is going to give me 4, 3, 8, even though 0 is at index 5. So if I want to include, you just have to remember, when you're specifying the upper bound, do you want it to be inclusive or exclusive? I could say 6 here, but I'm going to say 5 plus 1, which seems a little redundant. Like, why don't I just say 6? But the reason I'm doing that is to show you, in this case, we want to be inclusive of that upper bound. So you're just thinking about if I want to include that upper boundary, I add 1. If I don't want to include it, I just don't add 1. So this is inclusive, so we add 1. This is logically identical to just saying 6. It's not, it's just sort of a, I'm trying to demonstrate the idea of wanting it to be inclusive. Cool. Now, let's say I only want every other number. So I can specify a step of 2. And this should give me, let's actually go 5, 6, 7. Let's go to here, right? So this will give me 4, 8, and 1. Right, so this will be the step, the interval to use between the numbers. Right? Here's an interesting trick you can do with a slice. You can specify, remember we talked about negative indices? You can specify a negative step. If you specified -1 as a step, right? Because the assumption is that +1 is your step. If you don't plug anything in for the step, it's going to assume +1. You want every number in the positive direction. If you supply a -1, it's going to go, since it's negative, it's going to go in the opposite direction. It's going to go from right to left. And since it's a step of 1, it's going to do every number from right to left. So this is a de facto reverse. So this is important. Sometimes you'll want to reverse a list. Is 4, 8, 1 a step of 3? So let's look at this real quick. 4, 3, 8, 0, 1 is a step of 1. So what would a step of 2 be? We would skip 1. So we don't start here when we count the step. We start at the next one. So 1 step to the right is 4 to 3. 2 steps to the right is 4 to 8. 3 steps to the right is 4 to 0. So, oh, you just said never mind. Apologies. I totally didn't see that. All right. Good. So slicing can give you a portion of the list. It's also worth mentioning if I don't plug in a value here in one of these places, it's going to assume a value for me, right? So if let's say I want everything from 4 all the way to the end of the list, I'll specify the index of 4, and then I just won't specify anything else. If I don't specify a stop, it's going to just assume that I want to go all the way to the end. If I don't specify a beginning, let's say I want the start of the list all the way up to 8. So that's 2, 3, 4. I'll specify a stop here. Obviously, I want it to be inclusive of that 8. So we'll say 4 plus 1. So this will be from the beginning of the list up to the index that I specify. And I wanted it inclusive, so I'm adding 1. And then, of course, in the reverse example, right, like I specify a step, and I don't specify a start or a stop, so it assumes that I wanted to start at the beginning, and it assumes that I wanted to stop at the end. One thing, a pitfall here that I see people do is where they say, okay, well, I want to develop a simple rule of thumb, which is often just fine, and they'll say, what can I always supply here as as just to have something in place, just so it's explicit and clear. I would just say, don't do that. If you want it to stop at the end, leave this empty. If you want it to begin at the beginning, leave that empty. If you want this to be in steps of +1, leave that empty. If we don't specify anything, we're going to get a different list back. But it'll have all the same elements in it, but it'll be a different list. Ooh, we're running real short on time. Apologies, folks. Let's see. I'm going to skip nested lists for now. This is kind of interesting. I did say I would get to this, but it doesn't come up that much. It will come up in our material at some point, but you'll hopefully have enough practice under your belt with lists to get through that. Mutability. Well, we're about to, you know what? I'm going to need to pick this up. We'll wrap up here for today, and I will pick up the slides from nested lists on Monday, and we'll get through from nested lists there. Because we're going to get into mutability, and this is a topic that deserves more than a minute. All right, cool. So apologies. There's a lot of material to get through in these first few days, and it just can kind of go pretty fast. I find the time flies by pretty fast. So cool. So you all are free to go. If you're ready to go, wrap up and have the rest of your Saturday. If you want to stay around for questions, it seems like there's some good questions being asked. If not, that's totally fine too. You're welcome. You have a good weekend too. You're welcome.